Okay, so you need to do this. Go to google.com, and type in UCSC genome table browser. And then you're going to get a list of everything that comes up with that. If you just do UCSC genome browser, it's going to be a different page than what you want. So if you forget the word table, you're going to want to look for something with a yellow background when you open it up. As you'll see, this page is a yellow background. That's where you want to get to. So we're going to do clade mammal genome human assembly. You have to know your assembly for whatever species you're working with. It won't always be the most recent assembly. For the human, GRCH38 or HG38 has one other name, I'm not sure, off the top of my head. HG19 is another common one, but we're going to use 38, and you just know for whatever species. Like when I worked with cow, it was UMD 3.1. I don't know what the current mouse one is, but just know that it won't always be the most recent one. So if you all of a sudden see February 2020, a new genome build, you don't necessarily want to use that. Sometimes newer builds are not as effective as older ones, or they have an error they might be better genome builds, but they have an error in the specific spot where you're looking. So that's all stuff that you just have to know. Group, go to all tracks. I'm not sure where this is. And then scroll down to the bottom, and where it says snow/miRNA, we're going to click on that. Table, wgRNA, that's whole genome RNA. If you want to learn more information, you can click on describe table schema, and you can learn a little bit. The nice thing about working with bioinformatics and genetic stuff, genomic stuff, transcriptomic stuff, is that usually you can find a lot of extra information. You can pretty much teach yourself if you just click around on things or take the time to read extra information that's provided. So that's kind of nice. So whole genome RNA, we want, for the region, we want the genome. We don't want a specific position. And then leave these alone. Output format, go to all fields from selected table. Or, wait, let's look at the table. What we have, we actually just want the sequences. So select sequence, and then for output file, you want the source from where you got it from. So UCSC, then I'm gonna do wgRNA, snow miRNA. So you kind of want, in the name, you want to put the path of what you're working with. So UCSC is the web page, and then the track is snow miRNA. Table, there's only one option, so we're gonna leave that off. We did the whole genome, so we're gonna go ahead and put that in, genome. And then send output to Galaxy. So plain text is fine, get output. And it's gonna send it to Galaxy. Oh yeah. Right now we just want 5' UTR. Actually, we pretty much just want the CDS, but go ahead and do 5' UTR, CDS, 3' UTR, and one FASTA record per gene, and all uppercase, and then send query to Galaxy. Okay, and then that's gonna send it to Galaxy. If you already have stuff on Galaxy, it will disappear. And you can see here, like, I'm not logged in, when in reality I am logged in. So don't worry about that. that's just how it works. You can combine this with your other grouping of galaxy. But before we do that, we need, as well as the sequence, we need the GTF. So GTF, gene transfer format. GTF, GFF3, all of those are the same thing. It's just the information on, it's like the annotation. Get output, send query to galaxy. And whenever you're getting the sequences and the GTF, you want to make sure the name stays the same, because as you go through your data, usually you'll end up with several references. So this is our reference genome now. And you will, it didn't keep the name. So I would change this name to what we had named the file previously. But you will end up with several references, and you will forget where you got certain references or what settings you used. So I am actually going to go backwards, and I'm going to copy this name that we had, then go forward, and you can click on this pencil, and I'm just going to rename it. This is the FASTA, so .FASTA, save. And then on this one, this is the GTF, same thing, .GTF, save. Okay, you'll notice that with a lot of stuff in bioinformatics, you never use spaces, you use underscore. That's because if you have to use command line, you don't use spaces, pretty much. You try and avoid spaces. So underscore, sometimes it'll change it itself. Sometimes it's probably good practice just to always use underscore instead of a space. So this is now our reference genome and our reference GTF. From here, you will map the FASTA files, your subject FASTA files, which you derive from the FASTQ, onto the reference. So that's it for this video.